This is section 7.7, approximate integration. So for this section, we're going to just approximate integrals. Sometimes an integrand is too difficult to integrate, so we have to resort to an approximation method. So the first rule is called the midpoint rule. So we're going to, in this case, they're breaking up the integral into 4 rectangles. And then you're going to use the midpoint of each rectangle to determine the height of each rectangle. So you're going to have the length times the width, or the base times the height of the rectangle. And if you add those all up, that's going to give you an approximation of the area under the curve. So here's the base. Delta x is this length. And then the height of each function is given by f of x bar, where x bar represents the midpoint between these two endpoints. So there it is. All right, so notice that there's only 4 heights, 1, 2, 3, 4, when there's 4 rectangles. The trapezoid rule, you're going to connect all the endpoints, and these are individual trapezoids. So you're adding up 1, 2, 3, 4 trapezoids instead of rectangles. And so the formula is going to look a little different because it's an area of a trapezoid as opposed to an area of a rectangle. And the main difference you want to notice is that it's delta x over 2 in this case. Over here it's just delta x. And then the first height is just going to be f of x0, and then all the middle ones, or all the in-between heights, are going to have a 2 as a coefficient, and the last one is just the same as the first, coefficient 1, coefficient 1. All right, other than that, it's basically the same, except that you're going to use 5 heights as opposed to 4 heights. Over here, you're going to use 1, 2, 3, 4, 5 for 4 rectangles. And then the Simpson's rule is similar to the trapezoid in that you're going to use 5 heights, 1, 2, 3, 4, 5, for 4 rectangles, or 4 sub-regions. And also you're going to divide by 3 instead of dividing by 2 for the Simpson's rule. So let's take a look at an example. The first, the one example we're going to use is this, and we're going to do all 3 rules. So first thing I always like to do is graph the integrand. So if you were to use your graphing calculator or Desmos.com, then you would see that the graph is going to look something like this. We're going from 0 to 2, as you can see by the limits. The graph is going to look something like this. It's going to kind of go down and then go like that, something like that. So let's calculate delta x. It's going to be b minus a, which is 2 minus 0. There's your b minus a divided by n. They want 8 rectangles or subregions, so we have to divide by 8, and this is 1/4. All right, so by the midpoint rule, since we're doing part A first, the midpoint rule says that the approximation of this integral is going to equal to delta x, which is 1/4, times the, so let's kind of draw out the rectangles. So we got, that would be 0.5, that would be 1.5, this would be 0.25, 0.75, 1.25, 1.75. So if you were to draw these, it's going to look, you're going to take the midpoint, which is kind of hard to draw because this is pretty small, then the next midpoint, then the next midpoint, so on and so on. So we're looking at the midpoint of each of these endpoints, and that's how we draw our rectangles. So the midpoint between 0 and 0.25, the way you find midpoints is you add these two numbers and divide by 2. So if you do that, you're going to get each of these midpoints that we need. So the midpoint between these two would be, let's see, it would be 0.125. You can use fractions or decimals. I'm going to choose to use decimals in this case. The next midpoint, which is between 0.25 and 0.5, is 0.375. The next midpoint would be 0.625. The next midpoint is 0.825, and so on and so on. I'm going to have to write down here because I'm running out of room. All right, so now you can make use of your graphing calculator if you have one. Hopefully you do, or any kind of calculator to determine what the value of this is. And I've already done it, so it is approximately equal to, I'm going to round to 6 decimal points. So that would be 1.041109 if I round to 6 decimal points. All right, so that is how you do the midpoint rule. Now let's take a look at the next the trapezoid rule, which is part B. Trapezoid, so this is midpoint trapezoid. So for the trapezoid, I'm going to draw the picture again. Actually, you don't need to really draw the picture all over again. For the trapezoid, we're going to use the endpoints. We're not going to use the midpoints, so you're just looking at the endpoints. So for the trap, if you look at the formula here, it's going to be delta x over 2, which is delta x is 1/4. So 1/4 over 2 times f of 0 this time, because we're starting at f of 0, which is this one, the first endpoint, and then the second, third, fourth, fifth, until you get to the end. So you no longer have to deal with those annoying midpoints, which is nice. And remember that all the interior terms have a 2 coefficient, and the first and the last have a coefficient of 1. So that makes it easy to remember. So it's going to be f of 0 plus 2 f of 0.25 plus 2 f of 0.5 plus 2 f of 0.75, 2 f of 1 plus 2 f of 1.25, and once again I have to continue down here, f of 1.5, f of 1.75, and finally the coefficient 1, f of 2. All right, so they all have coefficient 2 except for the first and the last, and we are only using the endpoints, no longer the midpoint. So 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, and 2. All right, and same if you use your calculators, which I've already done. I got 1.040756 if I round to 6 decimal places. All right, and the final rule is Simpson's rule. And for Simpson's rule, if you look up here, it's going to be delta x over 3 this time, which is 1/4 over 3, which is 1/12. All right, and similar to the trapezoid rule, the first and the last are going to just be coefficient 1. And then they alternate. They go 4, 2, 4, 2, 4, 2, so on and so on. So that's what we're going to do here. So we start with 4. So if you start with 4, coefficient 4, well, I mean, actually the first one starts with just coefficient 1. The next one starts with coefficient 4, 0.25, and then 2, 0.5, and then 4. It just alternates 0.75, and then back to 2, 1, and then 4, 1.25. Then I'm going to have to carry on down here, 2 again, 1.5, and then 4, 1.75, and then 2. Actually, no, the last one is coefficient 1. Remember that. So it's just f of 2 for the last one. All right, and now using our calculators, we should get 1.042172 if you round to 6 decimal places. And that is how you approximate using those 3 different rules.